Today's lesson is on the idea of finding the surface area of 3D objects if all of the faces are flat. There is no special formula for this. The surface area of something with planar faces is the sum of the area of all the faces. What part of maths am I talking about if I say sum? There's add, subtract, times, divide. If I'm summing things together, what is it? Adding. So the surface area of something that has flat sides, you just add all the areas of the faces. Can you get that first block down, please? You just have a break. You watch. You've been busting your gut today. I'm happy with that. You're the only one of that group that's actually doing what I've asked you to do, yeah? Okay, moving down. You French girls, you probably know these by memory. Everyone else? I'm reminding you. That formula that you got there, sum the area of all the faces. If I'm saying to do that, I'm assuming that you know how to find the area of a rectangle, how to find the area of a triangle, how to find the area of a circle. Do you know how to find the area of a circle off the top of your head? No, the circumference is how far it goes around a circle? No, you don't. Do you know? See? How do I find the area of... you want to know those other two. So this is your chance to get the formula down for these shapes. You don't have to remember them, but I'm showing you how to find them so that you can use them later. How do I find the area of a square or a rectangle? You times the length by the width. How do I find the area of a triangle? It's the base times by the height divided by 2. Does anyone know why that formula works? If I drew this around the triangle, what am I trying to show here? Every triangle is half of what?
A square.
That's not a square. A square is this. Every triangle is half of a rectangle. That's why that formula works, because it's telling you to find the base times by the height, and then you halve it. Get those down because you'll be hammering them today. I'm asking you to answer 4 questions today. The area of a circle is pi times by the radius squared. Get that down. What's a parallelogram? It's a rectangle that someone's pushed over slightly. So a parallelogram is just the base times by the height. What can you say about the height, though? Is the height at an angle, or is the height straight up and down? The height is at an angle. If I'm like this, if I'm bent over like that, my height is going to be lower than if I was standing straight up and tall. So just keep that in mind. Height is always straight up and tall. Yeah? Can you get those 4 down, please? And I'll go over trapezium. And then you can start on the actual filling out your booklet. Can I just double check, please, whether you people know how to use formula? Because, okay, we're getting real back to basics here. If I knew that the length of this rectangle was 10 and the width was 5, how do I use those numbers in this formula? What do I do? 10 times 5. You plug the length into the formula and you plug the width into the formula and you use a calculator to find the answer.
Or your head if you're good enough.
Or your head if you're good enough, okay? Is anyone still getting those 4?
Yes.
While we're waiting for these people, does anyone know what a trapezium is? Can you mime the shape of what a trapezium is? Do it again. Yeah, good. So it's parallel, the top and the bottom, but one side, the top could be shorter than the other. So it's almost like a triangle, but the top of it's flat. Okay? So for anyone that's still going, you can get it after. The area of a trapezium is this. Can you get that down? And we'll do this answer together. The trapezium. How do you find the area of a trapezium? You find the length of A, you add it to the length of B, you divide that answer by 2, and then you times it by the height, which is straight up and down again. Those are the only shapes that you need to be able to find the area of at a Year 10 level in South Australian schools. And because you know how to find these 2D shapes, let's see if you can find the surface area of this house for gremlins or whatever would live in this tiny little place. Garden, no. There was one time they used to have muck-up day at this school, and that the year 12 just put garden gnomes literally everywhere. They were like in fridges. They were all over the place. Like 3 years later, you'd open a door and there's a garden gnome just looking at you. If I wanted to find the surface area of this 3D object below, which shapes apply out of these? Rectangles and? Good. Is there a square on the bottom maybe? Yeah. On the bottom because it's 6 by 6. So no circles here. All right. The problem that we have, let's work out the rectangles at the bottom. Area, let's call this side 1. Are all the sides around? They're all the same. So area of 1. What's the length and width of 1? 6 times by 8. That's going to be 48. Square. Stop. Look at you. There are 4 of them. Yes. So 4 times area 1 is going to be 4 times 48. So you grab your calculator, 4 times 48, 192 square centimeters. I'll put an underline there because I need to add those up. Someone else from that desk. What was the area? Let's call the square under the bottom 2. What's the area of 2 going to be? 6 times 6, which is 36 square centimeters. I'll underline that because there's only one of those. Now you have to think a little bit. Do I know the height of the triangles at the top? That's not the height of the triangle. This is one of the sides of the triangle. Okay? It's at an angle. But when the triangle is straight up, no, not quite. We need to use some other maths to find out. The 4 is telling you how high the triangle is standing straight and tall. Okay? So you need to use, have you heard of Pythagoras before?
Yeah.
We need to use Pythagoras to find that. So if I want to know the height of the triangle is this line that goes down the middle of it. Because the height of the triangle is wonky. It's at an angle. I need to know how long it is standing up straight and tall. So that's a right angled triangle that goes into the center. Closer. Don't rush. How tall is this vertical line in the middle of the pyramid? That's 4. That's what you said. That's what she said. 4. And how far would it be from the center of the pyramid to the edge? 3. So use Pythagoras. 3 squared plus 4 squared equals h squared. 3 squared is 9. 4 squared, 16 equals h squared. 25 is equal to h squared. What number do I times by itself to get 25? 5. So h is going to be 5 centimeters. Do I know how tall the triangle is now? 5 centimeters. How wide is the base of the triangle? 6. So now area, let's number this triangle. Let's just go area of triangle equals base 6 times by height 5 over 2. What's 6 times 5? 30 over 2. What's 30 over 2? 15. How many of those triangles are there? So 4 times area triangle. 4 times 15 equals 60 square centimeters. Underline. Have I actually found the total surface area yet, or do I need to add some stuff together? But we found that. That was the 36. Add the little underlines together to find the total. So it's going to be total 192 plus 36 plus 60. 192 plus 36 plus 60. 288. That's your total surface area. That's an example. I'll stop the recording here.